Hello, this is Jacob Briggs. I'm here to talk about my hash table, and I would just like to preface that the project thing here said to use uh, like strings, um, and I tried to figure that out, but I couldn't quite get how to use strings instead of ints, so I made this example using ints like the example in class did. So, first we make our hash table. And then we set up the number of indexes, something to later set as how many indexes we'll have. And then we make a table, which is a list, which is where we'll store the stuff that's actually going into the hash table. And then we set up all of our functions, which we have a constructor, which we'll get into what each of these does specifically later. Then we set up an insert item, which just takes an int. We take a find item, which also takes an int. And then we get hash function, which also takes an int, and then we have display hash. Um, so out of there, we come down, the first thing we have is our hash, or the constructor up here. And what the constructor does is it sets aside the number of indexes to put values into. So it finds our number of indexes, and then it creates our table uh, list to have all of the spots that num indexes has. So it makes sure that however many we want, that's what we'll have. Not too little, not too many. Um, and then the insert item will take what we're inserting and put it onto the back of the table. That's what pushback means. It's going to put it on the end. It's not going to put it in front. It's not going to put it in the middle. It's going to take it and it's going to put it on the end of the list. Um, and all we do there is we take our int um, and then index. We use hash function, which is this one, and it returns the modulo, I think that's what it's called, of number of indexes to find where it's going to be linked, which index is going to be linked to, or what number is it's going to be linked to. And so what this does, and then it takes this, it takes whatever index we get from hash function, so it's going to take the modulo of what we are giving, what we want to insert, and it's going to find out, hey, whatever the modulo that is, push this key onto there. Um, and then what find item will do is it'll go through a for loop and see if we can find a certain piece of data. So first we grab the hash key or the hash index of our key, um, which is what we're trying to find, and then we come in here with an iterator. And what an iterator does is it starts at the beginning, and as long as it isn't at the end, it'll go through each one. Um, so it'll start at the first one, and it'll go to the second one, and go to the third one, and go to the fourth one, until it gets to the last one. And what this says is if our iterator happens to become key, what this does is we found it in the table, it'll say that, hey, this is here, and then it'll break out of the for loop, so that we don't keep looping through it. And then if it finds something that isn't in there, it'll just, nothing will happen. Um, and then so for display hash, what it does is it uses a for loop, and it'll go through each index number we have and first output that index number. So it'll go like 0, 1, 2, 3, 4, 5, however many we put in there. And then for each um, one in there, it goes through table with the same iterator. It'll start at the first one and it'll go all the way to the end. Um, and what it'll do is it'll put this little arrow for each one and put whatever the number is. And this will, if two of them are in one index, it'll effectively put them on the same one and not like on different lines and mess it all up. Um, and so we get to the main. Let me build so I can debug it in a second so we can look at it. So first we make our set of values, which is 5, 10, 15, 17, and 7. And we're going to make this so we set up values. Um, and that's going to be how we insert them. And then we take n, and n will be how many of these do we have? How many are in here? And then we come down here and we create a hash table with 7 indexes. So what that is we go all the way up here, it's the constructor. So it takes in our integer right here, and it'll say, which is our 7, and it'll say, hey, make 7 indexes. Simple as that. And then here, we'll go through each item we're going to input and insert them. So we set up another for loop, which is it starts at 0 and it goes to the n, which is however many values we have in here. So here would be 1, 2, 3, 4, 5. It would do it 5 times, and it would insert the value and what it's on. So it would start at 5, it would insert 5, and it'll go to 10, it will insert 10, go to 15, insert 15, go to 17, insert 17, go to 7, insert 7. And then what we do is we come down here and we use find item to try and find 15 and 6. 15 being in there, 6 which isn't. So let's go ahead, and then I have a system pause so we can show this off without looking at the last part yet. So we go through, and because 15 is in there, it says, hey, 15's here, but 6 isn't. So we're like, nope, there isn't 6, so you don't need to know anything about 6. I did try and set it up to say, hey, this isn't in here, but I couldn't figure out how to do that. I wish I could have given like, hey, you're trying to find 6, and it's not in here. How dare you try to find 6? And so last, we just go through and display all the values to show off that they actually do exist in a structure, and we just use display hash to do that. So if I press a key, and I'll go here, and it'll show 7's here, 15's here, 10 and 17 are here, and 5 is here. Those are all the numbers we input right there. And they found out what the modulo is based on 7. Or, yeah, it would be the modulo is up here on hash function. It would take whatever number is here, get the modulo of which number indexes, which we put in as 7, I believe. And it finds where it would go best and slaps it in there, and we can see right here that 3 has 10 and 17, showing that this one index can have 2 keys on it. But that's it. Thank you so much.